What shall we do this evening? One thing, I might be in a position to show you the edger running off of this thumb drive on a laptop. So I'll just scratch down a demo here. Another thing is the updates to the edger repo. Somewhere in there, we should ask Nick what's happening and get an update of all of the new and wonderful stuff.
The stuff I'm dreaming of.
That he's well, you've actually made a handful of changes since the snapshot of the that's on the thumb drive.
Some of them I haven't even told you about.
Exactly. Yeah. So, what else shall we go over? All right. Well, I'll just put down discussion. So, let me see if I can share my screen.
Well, let me give you a teaser. Unbeknownst to Pete and anyone, including myself, I have been. Originally, when Pete and I were looking for a project, we had talked to a company called GoWin about, and they make, dare I say, real FPGAs. And I have been just beginning about using Edger to communicate to much larger FPGAs than the dialogue stuff. Just real hardcore digital FPGAs on a wireless platform, which I think could be fun. That's not going to be in the one of the things Pete and I have discussed is how to time releases, and the idea, although I'm not going to demonstrate anything today, is that I will at meetings sort of demonstrate and talk about what I'm doing, and then at the next meeting there will be a new release. So we will be on some kind of a release schedule. The flash drives that that Pete has made are, if you don't use them with Gypsy, are worth taking a look at it. Put it that way. They seem to be stable. There's a really weird compiler error that occurs on some machines and not on others, and we have not tracked it down. If it occurs on your machine, then please, I mean, we're trying to work out whether it's just what the root cause is. So we're really interested in whether it occurs on other people's machines. Apart from that, the flash drive has a complete iteration of Linux, and it will run on Linux machines. I've done some work in terms of getting it to run on Windows machines. There's a utility I'm using called PNPN, which is not available on Windows for some architectural reasons, but there appears to be a workaround. I just have not dug into it as deeply as I might. But it's a Windows, the core code, the ESP code runs quite happily under Windows. It's the big aardvark thing that is has an architectural issue to do with the Linux has soft links and Windows doesn't, and that's a solvable problem. So that's sort of where where we are. I would like to, and Pete may or may not agree, but I would like to get the get some other people looking at it, get some feedback, and then sort of announce to a wider world what we're doing, because I'm getting fairly happy with the code.
Nick, I have a quick question. So, if we want to start playing around with this
Yep.
and have access to a Linux system, is that me that's the feedback?
Yeah,
Yeah,
that's
I
me.
mean it's does it run? Um, it
Well, what I was going to ask is, would you suggest going the make a thumb drive route, or going and actually downloading it and installing it on our Linux system?
I would suggest the thumb drives are sort of a stopgap thing.
No,
No,
you
yeah,
definitely.
definitely the latter, Don. The latter.
Yeah, I mean install it.
Okay.
Um, it's I have when it doesn't work, give either Pete or I a call. Give me a call when it doesn't work, and I will do my best not to answer the phone. Uh,
Noted.
yeah, but it's I want to find what installation problems there are. Generally, the Edge installation issues are more of my area, um, and so um, it's Pete has a very detailed. I think it's up to 700 or 800 steps to get things running, and they're very concise steps. Um, it's that should get um, the first part has to do with the installation of Linux on the thumb drive, which is already done if you have a thumb drive. The later parts have to do with installing and running the code. So if you have issues, basically with the flash drive itself, um, please, it's contact Pete if you have, if it doesn't compile, it doesn't make. I would like to know this, and I will try and fix it. But it's approaching stability. Put it that way. Uh,
Um, Apropos of that, uh, I've done a ridiculous number of installs and setups in the last few weeks, and I feel really good about it, actually. Um, Now, as for people with, oh, are you guys getting an echo? Let me.
No.
no,
No.
No.
Well, I am a little bit.
Okay, I think I fixed it. Yeah, good. Um, um, what the heck was I saying? Oh, yes. For people that don't have, that are Linux, that don't have a Linux system available conveniently, that's what the thumb drives are designed for, really. And so it's just a convenience item for somebody that doesn't want to uh, invest the time and resources and come up with another disk drive or whatever is necessary to for them to run Linux. But if you've got Linux, um, the setup and everything is way simpler than it used to be. Um, we were having to do outrageous things like patching code and doing all of these weird hacks to put things together, and that's all gone. And the configuration of the target is drastically simpler now that everybody is on the same page with their hardware. We've all got C3 based dev boards, except for Ron Craig, and his dev board is sitting over here waiting to get to him. Um, and so just before the meeting, I typed in a bunch more commands into the edger install underscore linux.sh script, which is in the top of the repo. I haven't had a chance to test that. My intention is to make a brand new Linux instance on a virtual machine, and then work through that script and get the bugs out, unless somebody is just chomping at the bit to try it out first. So if somebody's got a Linux system, they could run that script and see if it works. And the other big simplification is that you now get 3 icons on your desktop. And the first icon is called Change Wi-Fi. And I'm looking at it now. Those of you, oh no, that does work. Okay, sorry, I thought I had a little bug there. So the first thing is called Change Wi-Fi, and if you double click on that icon, it brings up an interactive script where you just have to type, answer some yes and no questions, and then put in your Wi-Fi SSID and password. So that's step 1 of running it. And then step 2 is the icon called Start Aardvark. And when you double click that, it brings up yet another terminal window, and it starts up the Aardvark JavaScript engine. And then the last icon is called Start Browser, and if you double click that, it starts up. Actually, it's hardwired for Firefox because I just realized, yeah, it's not quite as good as it should be at the moment. But the intention and all it is a shortcut to starting the browser and pointing it at localhost :8080. But if you don't have Firefox on your system, you can just short circuit that. Substitute that last step with a just manual operations. And the install on a Linux system, I think I've finally figured out the magic with respect to Python dependencies. And I'm kind of glad Carl's not here tonight because I used the word Python, and I don't understand Python very well. So, but Carl does very much so, and so he would be correct in the assumption that I might be very wrong that the Python is set up properly. But it's now creating what are called virtual environments, which means that the Espressif IDE keeps its Python stuff packed away in a little secret place in your home directory, and it no longer steps on your existing Python environment. So hopefully that'll be a big improvement. And anyway, once we get the bugs out of the install script, we should be wide open for everybody trying out the current thing. Now, some of your dev boards may not work. We didn't, when we had that build session, when we built the dev boards, they didn't get tested. Some of them didn't get tested. The ones I assembled for other folks, I did test, but there are a handful that are made, and I'm the guy to bother about the fact that the LED doesn't blink. But we're missing the other chunk of documentation that we're missing is to do with actually, Edge are actually running. Can you guys still hear me?
Yep.
Oh, okay. Everything got very quiet for a second. And what we need to do there is run the Edger in the browser and take some screenshots and just systematically go through the process of what it looks like and what the menus do and the tricks you have to know to get it started. There are currently some there's some debug features inside of it, and so looking for a volunteer to do that.
Hold on, I think I heard your name.
So anyway, that's the other thing. If I can make it through this this demo, I can perhaps show folks what the thing looks like. If this screws up again, I've got Plan C. So shall I go ahead and do that? Give it another try.
Go for it.
Okay, here we go.
While we're getting that set, the code that is being distributed has a bunch of it doesn't automatically, for example, connect to the ESPs. There's a somewhat cryptic message which says get menus, and then there's a message that flashes up. The newer versions of the code list all of the ESP devices, so you can have multiple devices that you can select which ones you are connecting to. So this is alpha code in that it's a connecting to the devices, and the searching for devices is somewhat, or it's awkward. That's sometime last week, we separated what I was doing from um, any releases, because otherwise you got a moving target. So the the version out there is at least 2 weeks old. The it now scans automatically scans for devices. ESPs, you can have multiple ESPs. One of the other changes is that the version that is out there is very much focused on I2C, which is what the dialogue chips are. The new version has a menu item which allows for other I/O interfaces, specifically Bluetooth or SPI, GPIO, LED. You've got, I think there are about half a dozen different interfaces, some of which are my versions of the code support, some of which are going to take a while to flesh out. But I needed to establish where the menu items that controlled what you are selecting, which of the I/O functions of the ESP you are selecting. When you select a something, when you connect to through the ESP to some device, it then, in the case of the SPI, for example, lets you. It shows you all of the the when in the case of the I2C, it shows you all of the I2C interfaces that are available. At the moment, I've got probably half a dozen devices, including a frequency generator, um, a, a thermostat, a thermometer, very hyper accurate, 1 millidegree thermometer, a pressure sensor. I've got about half a dozen devices, which are the ones I have around me that I can connect into. The big one for me, besides the dialogue chip, is going to be the go-in, the larger FPGAs. And I have, I'm sort of looking at that out of the corner of my eye. So that will give you, that turns the ESP into a pretty powerful engine in that you've got you can have a 2,000 or a 5,000 element FPGA sitting off on a Wi-Fi hub, and you can do all sorts of rather nasty things. That's probably, 6 weeks away from even letting people look at that. But I'm trying to design the code so that I can do all of that stuff. So the menu structure is awkward at the moment. I'm going through and making it much less awkward. And if we cannot demonstrate the menu structure today, then Pete and I will put together a video which we will post of exactly how the menu structure is currently working. It will change. It is clunky at the moment. I know it's clunky. I've been working on the declunkifying it, and that's but the a lot of what I've been doing is with the architecture, particularly in the JavaScript, is kind of it is not esoteric, but it is complicated in that you have overlap structures. You've got a number of things going on that that all have to work together. And what this code out there does is ensures they all work together. And the fact that I could connect to this ultra precision thermometer or this digital direct digital synthesis chip, which produces arbitrary frequency sine waves. The fact that I could connect to those very quickly is means that I haven't screwed the architecture up too badly.
Right.
It's and there's a key feature which is I want to put in that I have not yet finally worked out, which is the ability to connect to web pages which are out on the greater internet, and I'm not, that I'm still beating on. I will get that, but that's at the moment the only piece that I am missing. So you will be able to tell the ESP in a menu, look, I've got a dialogue chip and I've got a go-in FPGA on the same ESP, and it will connect, download the code, and give you some level of functionality of of all of those. It is Paul. There are some specific. Pete, can you turn your microphone down a little bit?
I'm back, I guess.
Okay, you're back. Okay. It's it's a good indication you're still alive, but which we all. But Paul, you had some devices you were interested in connecting to. I'm interested in what people want to see this do. I want to make it do something rather than having some pretty menus that make LEDs blink. This is not what I did this for. I want it to do something. So if there are, my ideal project was the ability to look at neuromuscular inputs. I'm not quite there. What do people out there want to do with this? I mean, you're all very supportive. Now I want to turn it over and say, what projects are you interested in? And
Okay.
maybe I can tailor my development in that direction.
Well, I have a variety of, if I may go, we could talk a little bit about it, but I've got a variety of monitoring devices, sensors, and output devices in an array. Um, and I need to, with some level of flexibility, be able to switch back and forth between devices in some cases, and be able to examine the data that they're generating. They're all I2C. And then based on the data, I'd like to be able to send some changes to some of the devices and tweak some response parameters.
And to that end, in the existing code which you're getting from Pete, the I2C is fixed somewhere deep and dark in the code where the sun don't shine.
Right.
I'm looking at changing that so that each device in the device queue can potentially have its own I2C clock. So you can support, depending on which devices you are using, up to 30 I2C devices that are on the same I2C address. So if you run the clock line down one device, the data lines are common. All the devices get the data, but you are controlling which device actually gets clocked. And if the device does get clocked, it will ignore the data. So by running separate clock signals to each of the devices, you can support, in the case of the C3 module, you can support 10 to 15 devices. I have boards that have up to 30 pins on them. So you could potentially, if the bandwidth is sufficient, you could potentially have 30 I2C devices. And in your case, the I2C devices were in the same address. Um, we can uh, 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 we can support 30 devices at the same I2C address, is what I'm getting round to trying to say.
Okay.
Whether bandwidth will do that is questionable, but the addressing space, by doing the switching the clock around, will allow you to do that.
Any thoughts on what the polling rate would be?
I didn't quite get that. You were breaking up on me a little bit.
Any thoughts on what the polling or the update rate might be?
I don't know. I don't know what the initialization time is yet. It should be fairly minimal in that it's a mux, and that's part
Right.
of why I'm looking at the go-in chips, because at that point you can support, you can have all the devices running simultaneously.
Okay.
Not quite there yet.
Okay.
But trying to it is looking at your use case, and I'm at the moment my interest is in understanding use cases. I have my own little egotistical use cases that I am interested in exploring, and uh,
Sure.
my horizons need to be broadened. I need to see what other people might do with this, so that I can say, okay, as in the case of you, I can I can change the addressing so that you can have, not an arbitrary, but you can have a number of I2C devices which are on the same I2C address, and they'll all happily play together. That's one example of how how input changes the architecture.
Okay. No, that sounds good. That's very useful.
In my application, I want to monitor some number of phototransistors, currently 8, and
Okay.
read the voltage off of the 8 of them and find the one that has the highest voltage or lowest voltage. I currently have an 8-channel A to D that is SPI interfaced, and I have to go through and poll it for each channel. And I'd love to have some hardware do that automatically for me, and it would just tell me what the level of the highest one was and which one it was.
Let me take a quick look at something. I already have the an A to D interface. I have the tabs and stuff for the A to D interface, and I don't know how many channels the C3 supports for A to D converters. There is a you take a quick look.
I mean, I'd rather not involve the main processor here. I'd rather have something out in hardware, in an FPGA or.
Okay.
But the C3 has at least 8. I think it has more than 8. It has 2 A to D.
2 A to Ds, and they each can be mux to, I think, one of a bunch of channels.
Yeah.
It's they're 2 12 bits, and they each can look up at the most 6 channels. So you've got 12 channels. The As I remember, and I'll have to double check, the A to D channels are essentially DMA type channels. They don't take any bandwidth away from the CPU.
Okay, that's good. They are shared with other GPIO
Yep.
things, so a lot of some of those pins may already be in use.
Well, it is. There is a you had some particular concerns about price, but there is a brand new C6 CPU which I've ordered some, and that should be that the ones I've ordered seem to have an unlimited. They got pins everywhere, pins to the right of you, pins to the left of you, and it's a slightly more expensive chip, and I have not gone through it in excruciating detail. I want to get one to play with. It is, but the go-in FPGAs are like $3 a piece. I think there's some even cheaper ones that have 32 pins. They can be made I2C compatible, and some of them are much larger. If you get up into the $10-12 ones, they have sort of more gates than I can count. But yeah, it is. Let me dig into this slightly. Let me have some more fun. But okay, if would it be acceptable to have 12 A to D channels that kind of did everything in background?
Yes.
Okay, then your wish is my command. It's I'm yeah, I will look at that very closely. And I think on the version that you have is you're working on the really low cost version, which is IO bound. You only have a limited number of channels. I've got some C3s on boards with a lot more channels. So it's but yeah, I'll take a look at the I want to make the A to D functions a almost a completely background process. What do you want to dump the data to?
I just need to know which one is the brightest.
Okay. Well, I will bear that in mind as I sort of unroll the code. Uh, the A to D is the GPIO is I've got a thing that lets you set blinky frequency, and I'm not going to I'm not going to belabor the GPIO. The A to D function does interest me a lot more. Bear in mind that the A to D inputs are somewhat glitchy. Um,
Well, then we ought to have some digital filtering afterwards or something.
yeah, it is. You know, you're presumably at a fairly low bandwidth, so when you switch, the act of switching tends to like make everything. I think it's a capacitive ladder that they're using on the A to D functions, which means you've got a load that kind of changes until it gets used to what you're seeing. I've noticed that it was putting glitches back down the pipe into, but that may not be the case for the C3. It was in the 8266. It was glitching, and I had to have buffer amps when I used that. It was glitchy as hell. Kind of upset me, but I hope they fixed that.
What's the sample rate, Paul?
I don't know. So this is for my laser, for my laser pointer, laser detector.
I mean,
Are we talking about needing the brightest phototransistor signal once a second or once a minute?
So the laser sweeps across the detector and will illuminate it for, maybe a tenth of a second. So
okay, that should be that.
I would like 50 hertz or something, or 30 hertz, or
That doesn't seem as though it will hurt that badly.
But is it not the case, Nick, that currently the programmatic interface is HTML?
Yes, but the that's gonna yes, it is correct that that's HTML. It is the A to D functions. I am exploring the A to D functions. They're the most sort of interesting in that they are the data is coming in. I've got to essentially buffer the data. So I'm presuming that the data is coming in at a fairly good clip. I buffer maybe 100 samples and then put it in a queue and spit it out as a JSON array. I could um, I could take a page that I have that looks like a spreadsheet page, and to make that page identify the brightest of the candidates is and to do that on the ESP side. The ESP side is the code load is fairly minimal. And I'm not saying I'm saying I will look at that as one of the use cases and try and explore that as I put the code together. I may get my panties in a wad when I do that. I may not. I don't know, but that's a use case that I will bear in mind as I put the A to D code together.
I have a question on Paul's application. I'm just wondering if it's sensitive to current. Would he need to know the current at all? And if he did, the FPGA had any op amps and resistors or programmable resistors, you could do a high side current sense on it too, in addition to voltage.
That's a good point. Yes, I do know how to do it. Um, yeah,
I can give you
as a,
give you a good reference. I have been using the Adafruit INA 219. I would prefer to use the 260. I think it's specifically a power sensing chip from Texas Instrument, but you can't buy them till 2024. But the 219 Adafruit has a breakout board and it works great.
Yeah, I have a couple of those.
well, what I can do, and architecturally, what I can do is, if you have 8 LEDs, if I hook in the 8 LEDs to 8 low impedance pull down lines on the ESP, and then I got to think that through. I may be able to use the dialogue, I may be able to switch between the which of the senses on the dialogue I use. Um, I got to think that through. I'm not entirely sure what I'm doing. Let me think. You know, let me think through this use case. I'm not going to, and I will see if I can flesh it out in my head, and then come back to you with some thoughts. I think it should be possible to do it on what we have, if we get a little clever, but I'm not 100% sure.
So as I understand it, Paul, you're just looking at the voltage drop across the phototransistor, from the phototransistor to power or ground, right?
Yes.
So it's really a voltage sampling exercise, which goes, is 100% compatible with the A to D without any mods.
Well, I say I will sort of I will bear that in mind as a use case.
Thank you.
But this does raise the broader question of how to handle kind of application specifics. The as the whole system develops, it seems like there eventually is going to be a need to support functional modules that kind of sit alongside the rest of the system to do some of these specific algorithms.
And that's and that is, I don't know whether I can. I'm not sure how to dynamically load code into the ESP. I've seen some things that say you can do it, because the ESP has a funny 2K window that it reads from the flash memory into this 2K window, and there are ways to do dynamic code. Um, the worst case is that so there may be a way to load C code dynamically into the ESP, but this is I'm not sure about that. There is I have experimentally um, there's a capital E on that. If you take a look, the JSON strings that trigger the I2C functions are chainable, which means that you can put any number of them together to make a sentence. And that's how I've done a number of the IO devices so quickly, is that I can do, read, write, which is often what you have to do to the I2C.
Right.
There is implicitly in that a language which contains the ability to do comparisons and loops. And I'm very, this is on the back burner of my burners with the pots overflowing. But basically, there is the beginnings of a language in there that is carved out of JSON scripts, and allows you to do conditionals and branches. And I was really excited because when I came up with this concept, I was just, I was pleased as punch with myself. I Googled it and somebody had already done it, but that's and so I may well steal their code. I can be pleased as punch later on. But there appears to be a language which is sort of embedded in the JSON script that allows you to do comparisons and loops and that kind of stuff. So that is, that would be that would be a very nice addition. And as I think I know whose code to use as inspiration. We will say, if I can't be first, I'll steal your damn code. So that's so the idea of being able to run code modules that look like JSON scripts. There's a and the that is when you load the ESP, there are provisions in the code to be able to store multiple dialog files and have them automatically load from the ESP when the system comes up. That's the beginnings of a language. That's that syntactically touches on the ability to create a language, and
Right.
I'm flirting with it.
But is it the case that in that circumstance there are HTTP transactions going on to fetch a value and
Nope.
no?
No, the what it looks like is that you have a JSON string which is an array, and that array has a conditional in it, and the entire JSON string, which is one I refer to it as a sentence, is sent out, which can contain at the moment it can contain a dozen I2C commands. If I put in the conditionals, they all execute and the architecture is such that that all executes and it's non-blocking, so that will come back eventually with an answer. So if you had you could have the languages are based on an archaic language called Lisp, which I happen to know. um, and but you would say, you'd say, I've got an array, find me the max in the array. That's a fairly syntactically, you would say, I have an array of JSON, uh, I have an array of items, 1 2 3 4 5. You'd have a command max, and that command would simply would execute. Let me see if I can get this correct. It would execute 10 A to D reads and then put those into an array, and there would be a command that says max, and it would simply return the value of the maximum. And that would be that's a single HTML transaction.
So the performance of that might be quite good.
Yes. That's what I'm that's where I'm trying to get to.
So can I get the ordinal of the max as well as the max?
Of course you can.
Okay.
You want the ordinal, the cardinal, the bishop? I will get you it all. Yeah, no, it's the max itself would be the value max would be returned as a JSON string with two elements to it. The first would be the value, and the second would be the index. And you would so the command syntactically would look like loop until interrupted, read 8. There would be 8 reads, and then there would be a max. The max would be returned to the system, would be a JSON string which could be stored or could be acted on, and then you do it again, and this would go on until you told the thing to shut up and stop.
So you could also get timestamps or
Yep.
whatever you happen to be keeping track of.
Exactly, and that's what I'm that's where I'm trying to get to, and there are all sorts of annoyances in the way, but architecturally, that's where I'm going.
Okay. Another piece of mind we talked about from a kind of a data collection perspective. There's a data analysis bit in the middle, and then there is data output on the back end.
Mm-hmm.
And I anticipate a variety of different types of data. Some of it would be digital, keeping a log of the input data, for instance, would be one data stream that we'd want to be able to capture and analyze at a later time or in real time as we're going along. I think it would also be important to be able to create waveforms dynamically and put those out. Certainly, you could do that as a digital signature, whatever the wave shape is. Slice
Well,
this out.
as I've done with Pete, the HTML stuff, and in fact, all of this agonizing work I'm doing in Aardvark is irrelevant, in that you can run this thing from Python.
Okay.
You can simply open a Python link to the device, and you are simply talking. You are there is no particular reason why you are limited to the HTML structure. You can when I'm debugging stuff with Pete, I will the first thing I I do when he says it doesn't work is I send him a curl command, which is a command line HTML get this thing.
Right.
And once the curl command works, then we can start going back and working out what else is broken. But
Right.
but it at its core, this is simply puts, gets, and a couple other HTML commands that can be run from Python. And all in that case, all that the Aardvark is a convenient platform to show you how to do stuff, and I use Postman as a platform to debug stuff. It's there is no you're not constrained. Now there may well be two versions, one of which is going to be is going to have to exchange passwords and is more highly secure, because
Right.
Carl will hit me if I don't do that.
Sure.
But,
Well, if you're going to touch anything medical, you're going to have to do that sort of thing.
yeah, and it's at the moment security be damned, because I can't troubleshoot.
It's got to work first, then you secure it. You can't do it.
I can't troubleshoot the security stuff while I'm writing the damn code.
No.
It's a man has to know his limitations, and that's way beyond mine.
Sure. No, you play with white paper data and dummy
Yeah,
it up.
it's but there are passwords and authentications already going back and forth.
Sure.
They're just not used.
Can we also by some mechanism generate control voltages?
Oh yeah. Oh yes. Oh, most definitely.
Okay.
It's
There's
I
both
would be
AC and
amiss.
DC.
Yes.
Okay.
It's one of my use cases involves creating several outputs of between 0 and 1,000 volts, which is slightly excessive for what you want to do as a medical application. But I'm moving piezoelectric elements, and I have to be able to,
Right.
So yeah, I mean,
Yeah,
it's
0 to about 70 is probably.
yeah, you don't, and one of the inherent advantages of this is that they are in um, the voltages are inherently off of they're running on batteries.
Right.
So it's you're not going to electrocute anyone. My 1,000 volt supplies are not running off batteries and scare the hell out of me.
Right. Yep. Yep. Good. Oh, it sounds great.
So it is, probably not the the idea is that if people can take a look at this release and we can establish that, it the skeleton is there, that you know that what Pete
Right.
has in terms of the pieces, it stands a goddamn chance in hell of working. Then when we meet 3 weeks, 4 weeks, whenever it is from now, I will have another release, um, which will have a bunch of the ugliness un, slightly more under control. Um, the release 6 weeks from now, um, I would like to, no guarantees. I don't know that I can do it, but I would like to at that point start contacting Ampower and a bunch of people and saying, I think I have some good stuff here.
Right.
I want to go further afield, and I want to get more people involved that can tell me, how stupid I am and how I've done things wrong and how they are going to fix it.
More learning. More
uh,
learning.
but if I want to be if I've got the basic architecture right, and I think I have, then that all falls into place. But maybe maybe 9 weeks from now, if we on a 3 week schedule, um, I'm I will have it, so I won't be embarrassed. At the moment, every time Pete runs it and I see the connect to menu item button come up, I cringe slightly. And I apologize for all of that. This is alpha code, and anyone who
Right.
uses it is somewhat brave.
Well, I will give it a go. There's a lot of this which is totally foreign to me. I mean, I'm going to need help, but I'm willing to trudge, slog, fight my way through it.
Well,
See what.
I will make sure that my I have a backup phone which is turned off at 5 o'clock. I will make
Right.
sure that everyone gets my backup phone number. Uh,
Yep. Sure. And,
I'm not doing debugging code at 2 in the morning. But feel free
well,
to
and I have a wife, and she's not going to allow me to be mucking around with this stuff at that hour.
yeah, I don't have a
So
wife,
you
so
won't
it's
have about hearing from me.
it may well be that one of the reasons I don't currently have a wife is that I tend to muck around with stuff at 2 in the morning.
Right. Well, I did this. This was my third. So
Okay,
yeah,
well, it's yeah.
there's
So
lots
I
of room.
yeah, it's no, I it's but I have reached that point in life where it's like, no, my body says we're going to go to sleep.
Yep.
Um, so but um, if between now and whenever the next meeting is, 3 4 weeks, I don't know when Pete's going to call it. We can get a couple people that tell me initially why the code doesn't work, and then hopefully we will, between Pete and I, we will work it out so that the next release that goes out there will be have a bunch of the ugliness removed, and will flow a little more smoothly. And that's where I'm trying to get to.
Great. This is the design and test part of the process, and as somebody I met from Bell Helicopter used to take fast and often.
What's the plan for getting a public aardvark server running somewhere in the cloud?
That is, Pete is in the process of moving my Edger.app. I grabbed the URL and put it out on a server just because Pete has a server that he has a relationship with. He's in the process of moving that to his server. Once that's done, I just put together a very quick and dirty WordPress server. Just picked one of the sites and connected it. Once we have, once the URL is converted to a server that we have slightly more control of, which is Pete's looking into, then we will then aardvark servers are I have a server running internally on one of my Orange Pis, I think it is. So I'm pretty sure that that runs Apache 2. So I'm pretty sure that the code will run Apache 2. Just have to that's that hope might be done for the next meeting. Pete and I have had conversations about exactly how releases happen, whether this is a series of GitHub questions that we need to get with Rob, because he's done more of that than and just get the whole how we do releases. I have a private repository which I just stuff in, and we need to. I intend to continue stuffing stuff into the private repository. It has experiments. It has dead ends, and hopefully this will all get to a release version, which will go into the public repository after Pete has tested it. We're going to have to work out exactly internally how that's done. It's a get series of it's doable. It's just exactly who's in charge, who's the parent, who's the child, and all of those questions. So we may end up sitting down with Rob next week and get that worked out. It's yeah, there's stuff to do. I'm now taking I won't bore you with the whole story, but I'm taking some courses at NC State. NC State, because I want access to the lab, and so my time is getting slightly constrained, but it's a course I probably could have taught, but I want access to the lab. But this will take a little bit of my time. Just fair warning. But the code is to the point that I'd be happy to work with other people on it. They might not be happy to work with me, but that's an entirely other question. I will take the silence as a motion to adjourn.
Seconded.
Okay.